Hi, my name is Katie, and I work in human resources, helping leaders drive strategy as it relates to people. I've worked in software, hardware, energy, but this is my first time working in the semiconductor industry.
Hi, I'm Dave. I have a PhD in material science, and I've worked in a variety of industries, including aerospace, optoelectronics, and semiconductors. Fun fact, I have a Guinness World Record for creating the world's smallest test tube using material science.
David, thank you so much for taking the time to meet with me today.
Katie, it's great to see you.
I remember hearing back in 2020 about a chip shortage and how it impacted car production. And that was an aha moment for me when I realized that semiconductors have an impact in our everyday life.
Now, normally when we think about the semiconductor industry, people think about logic chips and memory chips.
I'm familiar with logic and memory chips.
However, there's a whole class of specialty chips that sense the world, generate information, and then communicate it through the air. These chips are critical to connected devices, communications, automobiles, power electronics, and sensors. And these chips are part of what's enabling the era of AI. Today, I'm going to focus on sensor chips. I'd like to start with an example of a self-driving car. Let's start off with the way people drive cars today. I learned how to drive, and so my brain, my memory basically tells me what the rules of the road are. And that's basically like an algorithm. So when my eyes and my ears are sensing what's going on around me, that feeds into my brain using this algorithm and tells me, what should I do? Should I speed up? Should I slow down, change lanes, stop the car so that I'm driving safely? Now, there's an advantage for autonomous driving. Autonomous driving systems don't forget things, and they're also always on, always paying attention. AI never forgets anything. But the ability for the car to respond in certain environments is only as good as the sensors that are around the car.
Okay, that makes sense. Can you help me understand what Applied's doing to help with sensors in cars?
Yeah, so one of the key problems that we know exists in the industry today is the sensitivity of certain image sensors. So you want to be able to have a sensor that can be able to detect what's going on in the environment in really extreme conditions, very low light, or when it goes from being very bright to very dark all of a sudden. And so one of the solutions that Applied is bringing to market is a special type of material that you can deposit in between the pixels to help improve the amount of light each pixel captures, and that improves the sensitivity of the image sensor. That also then helps the car, whether it's driving at night when there's no street lights, or if you're, for example, driving into a tunnel, remain in control of the vehicle so that the operator doesn't need to take over the car.
That's pretty incredible. So really what I'm hearing you say is Applied's expertise is helping advance the sensor industry.
That's right. And with AI, sensors can be used in a really wide range of places. So one example is in wearables, you can measure things like blood pressure and heart rate. And those are used for potentially detecting whether you have a heart arrhythmia or some other health condition earlier than you would by just going to the doctor every 6 months.
Can you tell me a fascinating example that comes to mind with sensors?
Yeah, one I read about recently is relating to how we can understand our climate and how we can also understand climate change. Most of the ocean temperatures in Antarctica are actually measured by seals that have wearable devices attached to them.
What? Seals?
Yes. And as the seals swim around the ocean, you can figure out the ocean temperature in certain spots that are very difficult for anything else to really access.
So doesn't the world then need more types of sensors to feed AI models with even more information?
That's exactly right. We believe 99% of the world's data will be generated by machines globally. We can help our customers improve existing sensors and create new types of sensors that can enable a variety of fascinating applications.
David, thank you so much for taking the time to meet with me today and help me understand how Applied's materials engineering is advancing technology that we're seeing in our everyday life.
It's my pleasure.